Hello and welcome to the CS animation video over binary basics. To begin, let us start out with a representation that we are familiar with and examine it. This would be the base 10 representation of numbers. The reason that our numerical system is base 10 is because each place in a number can have the values 0 through 9. There are 10 possible numbers, so it is a base 10 number. Let's continue with the example of 384 and represent it based on its place values. To do this, number the places from 0 to 2 from right to left. Raise 10 to the place number. Now multiply each value in the place by the place number. Lastly, add all the numbers together and you get your original number of 384. First, we'll start with converting binary to decimal. Let's take the number 101001 as our example. First, start by labeling the places from 0 through 5 from right to left. Then raise 2 to those place numbers. 2 is used here because we are dealing with a binary system, which is a base 2 system. Next, multiply the place numbers by the place values. Add them together and you get 41. Now let's go the other way from decimal to binary. The process is a little different. We'll start with the decimal number 41. The first step is to find the smallest value of x, where 2 to the power of x is greater than 41. Here is a table with 2 to the power of a number. As you can see, when x is 6, the value is 64, which is the first number bigger than 41. Draw out x number of spaces, which in this case was 6. Then do the numbering we did previously. Number 0 through 5 from right to left. Take 2 to the number of the place. Start at the left. You want to keep subtracting the biggest place value from the number until you can't anymore. The best way to demonstrate this is through the example 2 to the 5th is 32. 32 goes once into 41. So subtract 2 to the 5th from 41 and you get 9. Since it goes in once, the value at that place is a 1. Continue onwards with the other places. 2 to the 4th is 16. Now the remaining number is 9 and can't be subtracted from 9. So place a 0 in that spot and continue. Next is 2 cubed, which is 8. 9 minus 8 is 1. Put a 1 at that spot because 8 can be subtracted from 9 once 2 squared and 2 are both bigger than 1, so those places will have 0. Finally, 2 to the 0 power is 1. 1 minus 1 is 0. Place a 1 in that position. Whenever you do this technique, you should always end up with 0 as the final remaining number. Now put the zeros and ones together, and you get 101001 as the binary representation of 41. Binary and decimal aren't the only representations of numbers. The next common way is called hexadecimal. It is a base 16 numerical system. This means that each place can represent the value 0 through 15. However, we can't put two numbers in one place. So the numbers 10 through 15 are represented by letters. Now let's convert from hexadecimal to decimal. Take the number A3b, the previous strategy applies. Number the places from 0 to 2 starting right to left. Then raise 16 to the power of the place because we are dealing with a base 16 system. Here's the important part of the table for reference. Then we just multiply the numbers at each place with the place values and add them together to get the decimal number of 2619. The other way also works similarly. We'll convert 2619 to decimal. Start by finding the smallest x such that 16 to the x is greater than 2619. In this case, x will be 3. Have 3 spots. Number them 0 to 2 from right to left. Then raise 16 at the place number. This is where it gets slightly different. For binary, the values could only be 1 or 0, so we just checked if the number was bigger. Now we have to take into account that the number in each place can be 0 through 15. We take the biggest place, which is 16 squared. This goes in 10 times into 2619 to yield the value 59. Earlier we would put a 1, but since 16 squared went in 10 times, we put a 10 in that place value, which is represented by an A. We do the same thing for the other places. 16 goes in 3 times into 59, leaving a value of 11. So we put a 3 in that position. Lastly, 16 to the 0 goes in 11 times into 11, so we put 11 in the final spot, which is B. We are left with 0 remaining, so the value is A3B. Our last set of conversion to cover is between hexadecimal and binary. To change the hexadecimal number A86D to binary, we first need to realize that 2 to the 4th is 16. This means that 4 binary digits can be converted into one hexadecimal digit. We will draw 4 blanks and number them as we had before. First, let's start with converting the AA as the decimal value for 10, so we are essentially converting 10 to binary. This is 1010. Next, we move on to 8, which is 1000, 6 is 0110, and D is 13, which is 1101. Now we put all the values together to get the binary representation of the number. Lastly, we go the other way from binary to hexadecimal. Split the binary number into groups of 4s starting right to left. If the leftmost group has less than 4 numbers, you can pad the front with zeros because padding zeros to the beginning of the number doesn't change its value. This case doesn't have that. Now each set of 4 binary digits will create one hexadecimal digit. 1010 is 10, which is A, 1000 is 8, 0110 is 6, and 1101 is 13, which is D. Your hexadecimal representation is A86D. Hopefully this helped, and thank you for watching. If you want more content like this, please subscribe to the channel and turn on notifications.